also very good. So without no wasting much of our time, because it seems I'm delaying some people in the room too. Some people I want to join and I don't want to. I'm trying to add people now, so that I can also add people also as other people are adding too. So yeah, I want to the person that's supposed to introduce our lect. I don't think she's here. No, she's not here. So she's not here now, but I will stand in gap for her. So because she actually called me before the meeting starts. So we'll go straight to introduce our guest so that we'll not waste much of our time. The person that will give us lecture today is Dr. Taiwo uh, Gabriel Omomole, hailed from Elisha local government in Ogun State in Nigeria. He attended State Maris College, Okitipupa, for his primary school education, and he obtained his BSc degree in computer science from Adekunle Ajasin University in Ondo State in Nigeria, with a notable recognition as the best graduate student in the department. Due to his excellent academic performance, he was retained as the graduate assistant and later rose to the rank of assistant lecturer and subsequently to the position of lecturer 2 in the institution. As a graduate assistant, he began his master's degree with distinctions from the Federal University of Technology, Akure in Nigeria, and received the Young Researcher Award on graduating after publishing 3 journals from his research. And a couple with the recognition, Dr. Omomole has won several scholarships and awards, including uh, two times winner of Ondo State Scholarship, 6 times winners of the also packed scholarship for undergraduate and postgraduate studies. He won a fully funded PhD scholarship for his doctoral degree program in data science at Stellenbosch University in South Africa. And then he has published several research articles related to Scopus indices. He's a professional member of Society, i.e. ACM, and professionally started his career as a data analyst working with a two firm and later as a lecturer and researcher in Nigeria. While in South Africa, he worked as a data scientist with 3 IT companies which develop profound his industrial experience in data world. And he is currently affiliated with Peace Research Institute Oslo as a data scientist and a senior researcher with the University of Guref, I hope I'm correct, Orhano in Canada. So permit me to welcome Dr. Taiwo. You are welcome.
Thank you so much, Mr. Biola. Thank you, OOUME alumni, for giving me this invitation to be here to deliver this excellent lecture. Thank you.
Okay, you can proceed for your presentation, sir.
Oh, okay,
So that,
okay.
yeah.
Please permit me to share my screen.
Share your screen.
Okay. Thank you. I don't know if we can all see my screen, please. Can we see my screen, please?
Yes, I can see your screen.
Okay. So today we are going to have a brief discussion about data science and what data science is all about, how it connects with AI, machine learning. Then we discuss the hype about data world. We've been talking about data here and there. We hear data, we hear this. So what's going on in data? Then again, we are going to discuss some data science career that is profitable to an engineer. Of course, the field of engineering is extensive. So we will look at some critical data science career that is profitable, the fourth industrial revolution. So, and here, these are the contents that guide today's lecture. First, we introduce ourselves to the world of data, then discuss some buzzwords, AI, data science, machine learning here and there, we discuss those things. Then we talk about data science career, just like what I said earlier. But if time permits, we'll just introduce ourselves to what we know about machine learning production cycle. So, what is data? Everything that we use, all of the equipments, the facilities, computers, devices, they generate information, they generate facts. So this fact, we have to make sense about them. Data is everywhere. The amount of data that is generated currently is so huge that we can't even use all of them. We have data sets that are relational in structure, images, your video, which is streamed, audio, stream data set, and textual data. All of these data sets are generated from different sources. So it is important that we do not only produce these data sets, we should make sense of it. So due to the use of various devices, that has led us to a pervasive data generation and led us to the era of big data, where we talk about the 5Vs, veracity, volume, velocity, and value, stuff like that. But in the real sense, are we actually using this data set? Do we use data set efficiently? Are we getting the right information from data, sufficient amount of information that can drive decisions, profitable decisions for businesses? Are we getting value from data? And the question is no. Traditionally, the answer is no. When I say traditionally, what I mean is conventionally we base our analysis on statistical techniques. You use different statistical analysis, regression here and there, stuff like that. But these techniques are limited in the current industrial revolution, where we have data sets that have no SQL, no structure. Data sets are complex, they have different formats. So that is why we need automated systems, we need automated solutions to extract valuable information from the data. So from there, we can see that we are connected together. When you talk to a friend, when you use your computer, when you use any device at all, you are generating data. We are in a world that is so connected, and we keep seeing data everywhere, anyhow, any location. We generate data every moment in time. And what are the sources? Just like what I said, you use your internet, your Facebook every day. As you comment on Facebook, you are delivering a specific information. That is, your comments are data. When you talk on your phone, you are delivering data. As we are having this lecture, we are delivering data. Although they are in streams, that is audio. So there are different devices that are used in the present world, and these devices emit data that can be used to perform relevant analytics, generate different insight. So based on the pervasive generation of data, we can now see that we have large volume of data because we can't use or we are not using this data set efficiently. So that led us to the era of big data, where we talk about huge volume amount of data. We talked about there are different inconsistencies and uncertainty in data. Data having different formats, videos, audio, structured data, textual data. These are data that have different formats. Then the speed at which data is generated has now increased extensively. What I mean by that is due to the use of various devices, that has increased the amount of data generated. But do we want this data to lay fallow without any usefulness or any value? No. So that is really important, and it's critical that we have to generate insight, value from the data. So we wouldn't want to go deep into big data. That is a whole lecture for another day. But the whole idea is, as we continue to use all of our resources, all of our devices, everything that we have at home, we are generating data here and there. So the idea that should come to mind is, how can you create value from data? That is the scientific question that lies in the heart of every data scientist. How can you make sense of this data? What is the value that can be created? We talk about different buzzwords. We have been hearing a lot of buzzwords. Some people are confused. They don't know how they relate together. Some are saying data science is AI. Some are saying AI is machine learning. So, people don't really know the distinction among these three words. How do they relate? AI, as we know, is just the basic idea, the basic. I mean, I will have to explain this in a simple and understandable language. Simulation of human intelligence on machines. The most intelligent entity is a human being because we can analyze its situations. We have ability to think logically. We can carry out computations. A lot of things that there are a lot of things that a human being can do. So how do you want to simulate that intelligence on machine? That is the concept of AI. We have natural intelligence that is domained for human beings. Then we have artificial intelligence for machines. So everything machine AI is the large umbrella. Is that big umbrella that houses several components. And these are the subfields that we talk about when we talk about AI. Some people will say machine learning is AI. Machine learning is not AI. Machine learning is a subset of AI. There are different subsets of AI. We talk about expert systems, natural language processing, robotics, computer vision, machine learning. There are different aspects of AI. And machine learning is just one of the components. And from there, we move to the relationship between AI, machine learning, and data science. As you can see this diagram, AI houses machine learning. That is, machine learning is a subset of artificial intelligence. But then data science is an emerging field that employs that technique from AI just to, extract useful information from data. So when you talk about machine learning, it's just a technique in data science. There are a lot of techniques in data science. But the reason why we talk about machine learning is just the importance of the automated solution that it brings. So when you talk about machine learning, it's a subset of AI, but borrowed or leveraged in data science to process and to analyze data. So this picture tells us how they interconnect together. As you can see, data science is outside that set. You can see that machine learning is a subset of AI, while data science connects with machine learning. So it's a tool that is used to be processed, to analyze, to extract values from data. So what is data science specifically? We know about there is what we call data analysis, fine. Data analysis has been in existence for so many years. Then what is the science in data science? So it's just an investigation where you answer some critical questions using innovative approaches, not just your statistics. Yes, statistics is the foundation, is the baseline for data science. It is required in data science. You need the knowledge of statistics to succeed as data scientist. But then there are innovative approaches that are used to, generate actionable insights from data. Machine learning, deep learning, transfer learning, active learning. These are approaches. Recommendation systems. We have a lot of them. So to succeed as data scientist, it involves a lot of effort and a lot of dedication to learning, to gaining knowledge from several fields. As you can see, we have different disciplines that are connected together and are employed in data science. You need mathematics, statistics, advanced computing, data visualization, domain expertise. That is, you need to understand what is going on in the problem you want to solve, the domain in which you're working. For instance, you are working in the marketing company and you are told to tell us the possibility of getting more customers in the next 6 months. So it's more like a forecasting problem. So before you can delve into the problem, you need to understand the problem you're solving. There are two critical questions in data science. One, understanding the problem characteristics, and two, understanding the data. That is why we call it data science. So some people are so skilled in computer programming, you analyze your data, you develop your models, you deploy your models and all that. But the basic skill that is required is a proper understanding of the domain, that is the problem characteristics that you want to solve. When that is known and is well defined, then you need to understand, get the right data to solve that problem and understand the data. So those two things can now lead you into the selection of the right method and answering those questions with the right techniques and the right tools. So we have different application areas of data science. As you can see, we can apply it in travel, marketing, social media, automation, credit insurance, healthcare, sales. There is a practical example that we have to explain. When you watch a video on Facebook, for instance, you watch that video, you see that a similar video will be recommended to you. As you watch one, a video from the same distribution, or let me similar video, will be recommended. What you see in that situation is a recommender system that is based on the benefits of data science, specifically machine learning. So there are a lot of areas where data science can be used. And if you can see, all of these application areas, we talk about data. Huge amount of data is generated from marketing, from travel, you generate healthcare data, sales, credit, insurance, automations, social media. When you comment on social media, when you drop a post on social media, you are delivering data that can be used for analytics. So the current profitable question, if you are looking at going into data science and getting a career for yourself, the question that should come to mind every now and then is how can you create value from data? And data sets can be complex based on the field that you're working on. One, you can have data sets that are streams, audio, video. The basic format of the data that is very easy to work with is a structured data. I mean, when I say structured, I mean data sets in columns and in rows. But what if you have images where you have to extract information from the images? What if you have text? For instance, on social media, how can you extract? Okay, for instance, there's a video on social media and there are a lot of posts on the video. How can you analyze those posts and create value inside that? Okay, based on this post, some people are in support of the election of a so person, while some people are against it. So it involves a lot of, domain idea, understanding the domain idea, and the data itself. And as we move on, we talk about machine learning. If you can see, just like what I said earlier, it's just a data science technique. Some people, there is this hype about machine learning. Some people will say, I use machine learning to do this, I use machine learning. Then what is machine learning? What statistics can do, your machine learning can do that. The only or the major difference is that we are developing models that learns from data automatically without being programmed. Your statistics, for instance, you have a data set where you load your data set into, let's say, Starter software or SPSS software. You select a particular regression model, let's say linear regression. You want to look at the relationship between the level of income of people in Nigeria and age. Your linear regression can do that. It's just looking at the relationship between two variables and how you can create values from those two, from their relationship. But then what if we are talking about a data that has very large amount of dimensions, I mean features, and that is complex? We are talking about millions of data, for instance. Recently, I worked on a project, a kind of project on AWS, where we work on more than 5 million observations in the data, 5 billion rows or samples in the data. In that situation, applying a traditional statistical model, although it will work, it may work, but then it may not produce efficient result. Because there are a lot of context that comes into play. For instance, you talk about the bias variance complexity, you talk about the inductive biases, you talk about the model complexity, model architecture, and all that. So machine learning helps us to, create models that extrapolate rules in the patterns in the data and gives us what is going on. It tells us that, okay, this is what is going on in this data. And as we move on, the way it does this is through a number of or different algorithms. There are a lot of different algorithms that can be used. We have support vector machines, decision trees, KNN, convolutional neural networks, and all that. These algorithms, the way they learn on those data differs. Their goal, their target goal, then the size of the data set available, their learning strategies, which is related to their inductive biases, and as well how they represent data. When I mean, what I mean by data representation is that some algorithms can, work on data set that have missing values, while some perform poorly on data sets that have missing values. So they have, their pros and their cons. You just have to understand how they work. The basic task in machine learning is what we call the inductive learning properties. What this means is that when you have a data, the reality is that we don't have, when you want to solve a problem, there are situations in which you don't have a large amount of data to solve that problem. Sometimes data can be limited. For instance, in the medical field, you hardly see some data, when you want to solve a problem, maybe you're trying to create an intelligent model to analyze cancerous patients, maybe in a hospital. The reality is you may have limited data to answer such a question. So how can you, and the truth is you have to develop the model. Your client or your customer needs that project. So you have to get the available data, then you have to create your model using that limited amount of data. It involves a lot of domain knowledge in data science, understanding of the algorithms that is used. Then these algorithms, they have different parameters, and how can you walk through the data to ensure that you produce a model that generalized efficiently on the test data. So I wouldn't want to go into the mathematics here because that's not the goal for today. But this is just showing an overview of what machine learning is all about. That is, we try to obtain generalizations from different training samples and then obtained a model that does not underfit or that does not overfit or that has a kind of hot spot between the bias error and variance error. Is a lot of context that comes into play. Then we have different, learning methods. We talk about supervised learning, unsupervised learning, reinforcement learning, and unsupervised we talk about classification problems, regression problems. Unsupervised we talk about clustering, dimensionality reduction, association rule, market basket analysis, and all that. So this is just a representation, a basic representation of machine learning methods, which are supervised learning, unsupervised learning, reinforcement learning. I will give an example. For instance, if you go to a mall to buy maybe, let's say, beverages or something that, to buy milk or Milo, stuff like that, you will notice that the aisle or the shelf where you buy Milo and milk, they are always closed. Where you buy milk, you will always see Milo close to it, or in South Africa, we say Milo. So, in that situation, what informed the decision of the people in the mall to always bring Milo closer to milk? That is a simple analysis. So that is what we call market basket analysis. That is, there's a possibility of someone buying milk, then the person buying Milo, or then the person buying sugar. You will notice that Milo, milk, Lipton, those things are close. Tea and all that, they are close when you go to the mall. This is just a simple scenario of what we talk about under unsupervised learning. So when you are trying to, when you check your email, that's another example. There are some emails that comes to your inbox. There are some that go to your spam. In that situation, there is a model that tries to classify incoming mails to genuine email and suspicious email. That is email that are benign and the ones that are malignant. So it tends to classify them into genuine email and suspicious email. In that situation, the genuine emails will go to your inbox, while the suspicious will go to your spam. That's a typical example of classification problem. There are a lot of situations. Another thing is you're trying to predict the amount of sales for a product in a month. At the end of the month, you are trying to compute your profit. So you want to look at the amount of sales for, let's say, for Gary in a month. That is a regression problem. Then again, you are trying to look at the performance of a machine over 6 months. Regression problem. So machine learning has a lot of applications, a lot of them. Even at home, as you're doing your daily activities, you are carrying out a learning task. So here is just a pictorial look of some areas where machine learning can be applied or applied. Recently, we published a paper on we're trying to predict the safety risk level of construction work site using machine learning. It was really a good paper. So we have the machine learning applications in safety management, which is what we just did, in structural analysis, energy efficiency, material optimization, resource allocation, and all that. Then here, this is just we have different careers in data science, but I'll only be talking about 4, which are more critical. Because when I say critical, I mean a proper understanding of the role, the tool, the skills required in one of those 4 can make you to be successful in the others. When you talk about data engineer, you have a raw data that is collected from different sources. Very huge amount of data obtained from various sources. The data is raw. Then how can this data be pre-processed and stored for further analysis? That is the basic function of a data engineer. For instance, there is an ongoing issue in Nigeria regarding subsidy removal, and there are different news outlets, Punch, Daily News, different news outlets that have published information regarding the removal of subsidy in Nigeria, fuel subsidy, I mean. So here, you are told to generate a report about the current state of fuel subsidy in Nigeria. You don't have access to the national database of Nigeria where you can get the data about fuel subsidy, but you have access to different news sources that have explained, that have given values, given reports about fuel subsidy. So in that case, you as data engineer, you can scrape those websites. We call it web scraping.
Sorry, we have 5 minutes more, sir.
Yeah, I'm almost done. I'm almost done. I think this is just the last aspect. So in this instance, the data engineer tries to scrape information, get data, make data to be available for further analysis using various tools. Then the aspect here, the skill of data analysis is to perform data cleaning, exploration, visualization, and interpret the result. The major thing that is required for a data analyst in this instance is to use various data analytics tools, data visualization tools, and all that. And you can see the pay is based on the US salary indices is $47,000 to $89,000. Then data analyst is just being a data scientist is being a data analyst and having the skill to create intelligent models using machine learning, deep learning, and other strategies. So a data scientist extends the skill of a data analyst to the area of predictive modeling using innovative tools like machine learning, deep learning, reinforcement learning, and all that. So, and the last one is a machine learning engineer. Also, machine learning engineer extends the skill of data scientist to the area of software development. That is now a data scientist develops a predictive model to solve a problem. How can that model be put into use? That is, how can the model be deployed into a system, a real life system that can be used? So that is the extension in the skill of a machine learning engineer. It performs the role of data scientist to an optimal level, then includes software development skills. So a machine learning engineer has software engineering and system design skills, understand machine learning, have an in-depth knowledge about or about different programming languages. Then, as you can see, you will see that the salary of a machine learning engineer is quite high compared to a data scientist. So that's just an overview. If we had time, I would have possibly taken you through machine learning pipeline and all that. So that's just an overview of what's going on in data science, being a data scientist and what you can do. The question that comes to mind is, how can you create value from data? What are those things that you need to learn? What are the tools that are required, the skills that are required, and in what area do you fit in? So it's a very good question to answer. You can become a data scientist and also and be solving different engineering problems. You just have to know what you need, the tools, the techniques, and the skills you need to learn. Thank you so much for your time. So that's all from my
Thank
side.
you. Thank you very much. I'm so sorry to just to cut it short like that. Yeah, really, I thought I could continue. We should continue like that because I'm really enjoying the lecture and it's quite informative and I think probably me too. Maybe I will now try to think of going to data aspect. So
Thank
thank
you.
you very much, and we hope we'll be able to have access to the PowerPoint at least to share with
Yeah,
uh,
sure.
uh, alumni so that they can also read through. I just have a few questions because we only have 1 hour free subscription here. Google has changed its own policy. So before the Google will log us out, I just want to ask this question. One of our
Okay.
member is asking that is it possible for us to, where can we learn this all these programs or software that you are mentioning, is if like where we can get it for free or get it satisfied, and how can we get it to get a job, like in the case of like as a mechanical engineer. So I don't know
Yeah,
if you understand my
yeah,
question. Yeah.
yeah. The first thing that you need to learn is to build your skill. You need to build your technical skills. And you can do that by attending or by taking different maybe certifications. And also you have to read, watch different videos, get different books, read about data science. Then you can take certification programs. For instance, you can check Data Camp, you can check Coursera, you can check Udacity, you can check EDX. So these are companies that offer different data science programs. You can check AWS, you can check Google. Google offers different data science programs. So when you have that, when you learn and you have acquired relevant skills and experience, you can then check. There are a lot of positions on Indeed, on LinkedIn, on a lot of positions on Google Jobs. So the first thing is try to build your skills and your experience. For the next 6 months or 1 year, you can do that. You can achieve that within 6 months or a year. Take some certifications, work on data, real life. Get your hands dirty in programming and all that. So, and over time, you tend to build your experience. Thank you.
Thank you very much, sir. Thank you, Dr. Taiwo. Okay, maybe I should just give a few seconds. It's not because the time is quite running. If we have any questions in the house, we can just raise up our hands and then just press button. You see hand raise up button. Then I will um, I will answer. I will give you a free time to talk, just a few times. Okay, I have a question in the chat. He said,
Okay.
"Must an engineer be a programmer or application of a code for problem solving?"
Um, it all depends on what you want to be.
Mm.
If you intend to go into data science full time, obviously you need to know you need some level of skills in computer programming. Maybe for instance Python, but you can also apply data science in your field. Then in that sense, the level of skills that you need may not be equal to the level of being a real data scientist. So if you are looking into applying maybe machine learning in solving an engineering problem, then you only need to know some, some skills, SQL, a bit of SQL, a bit of data manipulation, data analysis, and a bit of computer programming. But if you are going to be a data scientist, you must have known all of these things and practiced them for a number of years. And also, you need to extend your knowledge to the area of software engineering. So I think that's how I can, answer the question.
Thank you very much, Dr. Tyro. Yeah. Maybe just before we round it up, I have a few questions. Just one
Okay.
question.
Okay.
So, thank you for the lecture. In this machine learning,
Okay.
um, is it a must for every? I mean, like as an engineer now, you said we can apply to as an engineer, we can apply to our studies and then
Sure.
or probably in terms of what area we are working upon.
Sure.
So yeah, what I would like to ask uh, is it also good for us to like in which area that we can actually apply it to? Is it just only for analyzing a data of information, or maybe in terms of, for example, now probably I have an analysis I want to carry out, or probably I have a information I want to carry out. Can I actually use machine learning, or probably machine learning for carrying out such information?
The most interesting thing about machine learning is, apart from analyzing your data, you know, building a model, applying that model on the data, getting your result, the level of accuracy, the predictive performance, and all that. Machine learning can actually be used to automate a process. For instance, there is this engineering problem that you're trying to solve, and let's say the problem is repetitive or it's complex. But before you can include machine learning, you should have data. A learning model needs data. I would have explained the whole process involved in machine learning if there was time. So when you are talking about analyzing data, getting insight and values from data, you talk about machine learning. And when your data is more complex and is huge, then you talk about deep learning. So in engineering, you can apply machine learning to solve different data-driven problems. You know, you are trying to maybe predict oil spillage in a machine, or maybe the energy consumption in an area, as maybe as an optimization problem, for instance. Because what machine learning does, it performs optimization. So you can apply machine learning to do that. And when you apply them, it gives you efficient result about the amount of energy consumption in that area, and also, different problems and different answers. Thank you.
Thank you very much. Thank you everyone for joining. We really appreciate your coming. Thank you for making it a date to be here, and we want to appreciate our lecturer. Let me put it like that, for giving us this wonderful lecture. I'm sure maybe next time, I'm sure you'll be able to answer us when next time we want to. Maybe you should come and round off the uncompleted lectures where you stop.
Thank you.
We really really enjoy the lectures. So thank you very much. So to everyone, thank you very much for joining. We don't have much time here. I could have said we should continue, but yes, due to time, we could not able to continue. So thank you very much for joining. I want to appreciate everyone in the room. Thank you, bro Adeyemi. Thank you very much. Bro Adesonya, thank you. Bro Mosu, thank you. Bolarinwa, Boluwatife, Olusegun, Taye, Oluwaseyi, Omotayo Redwand, Ogun, Owo, Larin, and then everyone, Yusuf, thank you everyone for joining. God bless you all.